Hey, honors. Today we're going to be talking about probability rules in genetics. All right, so that's, the main theme, but we're going to take a little journey and then we'll come back around to this. So let's talk about why we would need to use probability rules, or even why do we need to use math and biology? All right, so a couple weeks ago, we learned about monohybrid crosses. Okay, for monohybrid cross, remember we were looking at crossing one trait, right? All right, and then just yesterday we learned about dihybrid cross, and that's when we were looking at the inheritance of two traits. How do you do those problems? Okay, well, what are you going to do if you have a polyhybrid cross? Right, and what does that mean? Poly means many. Mono is one, di is two, poly would be many. So let's say, what would you do if I asked you to cross this fella? Okay, so what if this was the cross where we had to look at 5 different traits and their inheritance pattern? Well, if you actually did this, you would need to draw 1,024 boxes. Um, so a monohybrid cross gave us, it's just 4 boxes, easy peasy. Dihybrid, it's a little complicated. We have to use 16 boxes. And for this would be 1,024 boxes you would have to draw. So, it wouldn't be worth your time. It would take you hours to complete one problem when you could just use math, simple math, just multiplying fractions to speed that process up. So when do we use, so what is a probability rule? So we're going to talk about the rule of multiplication here. So let's just do like a really basic problem first, then we'll get into a Punnett square. Actually change colors. And we're going to do a basic problem. All right, what are the chances that you have 5 kids that are all boys? So let's write that. So this is an example of what probability is, or what the rule of multiplication is. So what is the chance, the chance of having 5 kids that are all boys? So what's the chance that you have 5 kids and all of them end up being sons? Okay. For your first, what are the odds of having a boy anytime you have a boy? What are the odds of having a girl? Well, every time it's a 50-50 shot, right? Half the sperm get dad's X chromosome and half the sperm get dad's Y chromosome. So every time a sperm's created, half of them, his XY, his genotype, his XY is going to split. It's going to go from diploid to haploid. So the sperm's either going to get X or it's going to get Y. So it's a 50-50 shot. So the first child you have, it was a 50% chance that you have a boy. The second child, you're still going to have a 50% chance of having a boy. The third, the fourth, the chance never changes. So just because you already had a son or you already had 2 sons, it doesn't change the odds of having a son a third time or a fourth time or a fifth time. Every time it's a 50% chance because half the sperm have X chromosomes, half the sperm have Y chromosomes. All right, so how would you do this, right? So we just are going to multiply this 1/2 by 1/2 by 1/2 by 1/2 by 1/2. So you just multiply across 2 times 2, 4, 8, 16 times 2 is 32. So this is a 1 in 32 chance of this happening, of having 5 kids that are all boys? I mean, things can be complicated because it does seem but it's not always 50% in every family, right? Some family have 6 boys and then 1 girl, or they have 7 sons and then they stop. So this isn't, universal, but for most people, it's 50-50. Okay, so that's just kind of an intro problem. So let's talk about how we're going to apply this to a Punnett square problem. So the rule of multiplication for genetics. All right, the first thing you're going to do when you see an ugly problem like this up here, so step 1, you're going to perform a monohybrid cross for each allele. So then you can determine genotype frequency. To determine genotype frequency. All right, and then after you do that, step 2, you're going to multiply the frequencies together. All right, let's do an example. Okay, so example problem would be, this is parent 1. And they're going to be crossed with parent 2. All right, so what are the odds that these 2 have a child like this? Okay, so what are the odds that they get something like this? Okay, so to do that, we're going to, right, this is the problem. We have to figure out the odds of having this offspring. So let's do step 1. Step 1 said perform a monohybrid cross for each allele. So we're going to perform crosses for the A's, crosses for the B's, crosses for the C's. So in this problem, you can see that we have 3 different ABC. We have 3 different alleles. So we're going to need to put in, let's draw in, we're going to do 3 monohybrid crosses. All right, so the first thing we do is we'll cross our A's. All right, now we cross, oops, I'll switch colors. Okay, let's go to green. All right, heterozygotes for both of these. Okie dokie. And then the last one we'll do are our C's. Sorry. Little c, little c. Big C, little c. Okie dokie. So then we do the cross and we get our frequencies. So okay, that's our A's. Here's our B's. You should be experts at these little crosses by now. Then we'll do C's. I do not like C's because big C's look like little C's, so you have to be really careful. Right, we had little C's at the top, and then we had heterozygous at the bottom. So that's a big C and a little c, big C and a little c, little c, little c, little c, little c. All right. Okay. So we have the crosses done. step 2, so step 1. Oh no, we have to finish. We have to determine genotype frequencies. All right, so let's put our different genotypes. These are all the possibilities. All right, so what is the chance that we would have homozygous dominant? That would be 2/4 or 1/2, right? 2 of the 4. Heterozygous, also 1/2. In this case, we have no homozygous recessive. Okay, for our Bs, we've got a 1/4 chance of having big Bs. We've got a 2/4 or 1/2 chance of having heterozygote, and then we've got a 1/4 chance of having a homozygous recessive. Okay, and then here, let's see, we've got a 0 big C, big C. We've got 1/2 heterozygous, and then we have 1/2 or 2/4 homozygous recessive. Okay, so now we can do step 2 where we multiply the frequencies together. Okay, so looking at our results here, so what was the odds that these two would have this person here? So first you have to say, what's our genotype frequency for heterozygous A? Here it is, so it's a 1/2. Okay, what is our frequency for heterozygous Bs? It's another 1/2. And for heterozygous Cs, also 1/2. All right, so we multiply that, 2, 4, 8. So we got a 1/8 chance of these two having this offspring. All right, that's how you do that problem. Okay, so now we're going to do the practice problem that is assigned to you today. So let's look at what I put on our Canvas page for today. So this week I tried to make it as simple as possible. Believe it or not, every week I try to make it simple. So this is what the page you're looking at. So for Friday, April 10th, watch the tutorial video that I'm making right now. And then that will be posted on YouTube. You'll be able to click and follow that. And see, oh my gosh, this is like weird. And you'll be watching this. So you would have already clicked that. All right, the next thing you have to do is do these practice problems. So let's open up that file. All right, so this is the practice problems. And this goes over everything that was in the packet. So this is the end of this first packet that we've done. So you've got this real basic stuff. This shouldn't take you too long. And like always, you can do it on this document itself, or you can just write it in a notebook and take a picture. It's fine. Then we've got some monohybrid crosses, more dihybrid practice. I feel like you did a lot of that this week. So, okay, another dihybrid. And then here, this last problem, this is the one we're going to work out together. You don't have to do it on your own. So we'll work this out together right now. And it'll take probably about 15 minutes to do just this problem. So we're going to do number 20. And this one says, use what you know about probability to determine the percent chance of each of the following outcomes from a cross between two parents with the genotype blip and this. All right, and then they give you 3 different offsprings, and they want to know what are the chances of having those offsprings. And then you'll see we're looking at 6 different traits. We're looking at 6 different alleles. So there's 6 Punnett squares already drawn. And then, yeah, so we're just going to have to get into it. All right, so that's the problem I'm working on. So it's number 20. All right, and it's a lot of letters. We got heterozygous A, heterozygous B, homozygous dominant C, heterozygous B, homozygous dominant E, and homozygous recessive F. is crossed with heterozygous A, heterozygous B, heterozygous C, homozygous recessive D, heterozygous E, homozygous dominant F. All right, those are the parents. And then these are the possible offspring. This first one is homozygous dominant everything. All right. I'm going to leave myself some space so I can do the math down here. The next possible offspring is, I kind of wrote that stuff again. Let me look back at the worksheet. Okay, so we've got heterozygous A, heterozygous B, heterozygous C, homozygous recessive D, homozygous dominant E, and then heterozygous F. All right, and then leave yourself some space because we got to do math. And then the last one is homozygous recessive A, recessive Bs, het C, het D, het E, and het F. Okay, so we got that. So now we have to draw 6 Punnett squares. We're going to have an A, a B, C, D, an E, and F. Hopefully you have some space on your page because you're going to need a space. So try to do 3 on a line. Like this. Leave yourself some space because we got to write out those frequencies. Okay. Alrighty, let's do the crosses. All right, let's cross our A's first. So if you look back at the parents, we're going to have a heterozygous A, heterozygous A. Okay, and then our B's are heterozygous, heterozygous again. Our C's are homozygous dominant and heterozygous. I'm going to try to exaggerate my little recessive C there. Okay, het D, homozygous recessive D. All right. E's, homozygous dominant, heterozygous. Okie dokie. And then F's, homozygous recessive, homozygous dominant. I like writing lowercase f's. Although as soon as I said that, I screwed that one up. Isn't that just poetic justice there? Okay, so now we do the crosses. We combine these letters. So I'm not going to talk through it. Just I'm going to be working it out. I don't think there's anything to say because we've been doing these for a couple of weeks. Okay. All right, so I'm going to switch colors to do the math part, just so it pops a little bit. Oh my gosh. The old girl's groaning. All right. Okay, so let's do our genotype frequencies. write out all the possibilities. These are the three. I think dots are faster than slashes. What am I doing? Whoops. I'm too excited about drawing a lowercase f there. Okay. All right, so let's do the geometric frequencies, and then we can come back up here and look at the offspring to determine what the odds of having those children are. Okay, so we've got a 1/4 chance to have homozygous dominant A's. We've got a 1/2 chance for 2/4 for heterozygous. We've got 1/4 for homozygous recessive. All right, this box is the same. 1/4, 1/2, 1/4, because there's two het crosses. This one we got to look at a little bit. We've got 2 out of the 4, 1/2 dominance. We've got 1/2 heterozygous, and we have 0 homozygous recessive. All right, for this one, we've got 0 homozygous dominant. We've got 2/4 or 1/2 heterozygous, and 1/2 homozygous recessive. Here we go. This one we've got 2/4, 1/2, 2/4, 1/2, and then none. And for this one, we have no homozygous dominant. We have 4 out of 4, or 1, 100%. And then we have 0 homozygous recessive. Okay. Now we're going to use this. These problems get hard, right? We're going to use this to figure this part out. So, what are the odds that these two would have a child with this genotype? All right, so we're going to just copy what we did. So, to get those two to have big A would be a 1/4 chance. 1/4 chance for B's. 2 big C's, hey, 1/2. Big D's, 0. I'm already liking this problem. E's, we got a 1/2. And then big F's, we got 0. All right. Can anyone do that problem in their head? I can. 0% chance. It ain't gonna happen. They cannot have a child with that genotype. I like that math. Okay, let's do this one. What are the odds that they're gonna have this kid? So we've got 1/2 chance for heterozygous A's. We got a 1/2 chance for heterozygous B's, a 1/2 chance for heterozygous C's. Homozygous recessive D's, also 1/2. Homozygous dominant E, oh my gosh, 1/2. Then heterozygous F's, 1. All right, so do the math. So we got 5, so that would be a 1 in 32 chance, which is around 3%, if you like percentages more. Okay, so they could have this child, and that's the odds of them having a child with this genotype, 3%. All right, last one. Here we go. Homozygous. 1/4 homozygous B's. Heterozygous. 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 All right. That's a 1 in 128 chance, or about a 0.8%. So even less likely, but hey, possible, possible, possible. All right, so that is it for this probability practice. Thanks for sticking it out with me. Hey, we're under the 30-minute mark, so that's exciting. And all right, that's what I got. Okay, have a good one.